The way I look at cars now, they're just computers on wheels. You have a screen, you have all these fancy things in there. So the attack surface has increased, I want to say exponentially, just over the past like 5, 10 years. So some of the things that you could go for are the infotainment systems. They will generally have Wi-Fi, Bluetooth, BLE. BLE is even used for locking and unlocking the cars as well as driving them now, because you have phone as a key. You have tire pressure monitoring systems that also use Bluetooth now. That's a great attack vector as well.
Today, I learned what it takes to pen test wireless devices. We focused on everything but Wi-Fi. I learned what hardware and software is needed to pen test cars, IoT devices, how to intercept cellular communication, and spoofing GPS. Check it out. Ayyappan, thank you for coming on Ahead of the Breach podcast.
Thank you for having me, Casey.
So you're an expert in everything wireless hacking. So I have a bunch of questions for you today because I want to learn so much about this space and the things that you do. But first of all, why don't we start with what's some of the wireless testing that you do day in, day out?
So personally here at Block Harbor, I work mainly with the VCL team, where in wireless, I test everything that has a radio on it. It can be anything from a key fob, Bluetooth, Wi-Fi, GPS, and my favorite, cellular, and everything connected.
Nice. What are some of like the latest attacks that you do? What are the most prevalent attacks that you do, say, if you're testing something with a RF fob?
So with RF fobs, there's a lot that you can do. You can do anything from a basic replay attack where you can just copy and send the same signal again. You can test for other things where the timing is off, so you can essentially roll back the keys on the key fob and still use an old valid code, send that, as well as if you have physical access to a key fob, you can also connect it to a variety of devices like Cellular and things like that, and extract logic as well as firmware sometimes from the key fob and do some fun things with that.
Interesting. So if you're extracting firmware, what are you looking for?
The ways, I would say the algorithm behind it, and sometimes it's also easier to get the exact message from the key fob itself so that you don't need to decode anything wirelessly, because all you need is the data sheet for that particular chip, as well as reading SPI, I2C, or whatever communication protocol it's using on it. And you basically have the keys to the kingdom.
Nice. So I should have probably started off this, question with like, how do we steal a car? Right? But we're ethical hackers here, so we're going to dive into the methodology of the testing. So when you're looking at, extracting firmware, looking at the algorithm, sniffing to basically see how the algorithm works, what are some of the things that you're finding? Do people like roll their own and try to make up their own algorithms in their own way of communicating, or is there pretty much industry standards?
It depends. So there are industry standards for some of them, but from what I've seen, every automaker has a certain vendor that they go to, and they have different ways of implementing the same thing over and over again. So in different ways. So even if it's a Japanese OEM, for instance, each of them have their own different algorithms and things like that, which are completely independent of each other. And it can vary within an OEM just based on different models and years, of course.
Now, back in the day, you were able just like to record the sequence and then play it back, right? And you could do that with a HackerF. Nowadays, you can do that with all sorts of different tools. But let's start there, like old replay attacks, right? Like maybe they're not a thing anymore, but like what would be the tools that you would use to do any type of replay attack?
So on the cheaper end, you of course have anything that's an SDR, a software-defined radio, or anything that has a radio transceiver you could use to essentially do that. So a HackerF is a great starter tool to get into. You can personally get one on Alibaba for about 120, 130 to start off. You also have the Flipper Zero, which is another great tool, which is far more easier to use than the HackerF itself. But if you really want to get more information and learn things by yourself, I definitely recommend going they're out of an SDR like the HackRF.
And can you still do this with even the cheaper route with like the RTL 2832, I believe it is,
Yeah.
the
So
USB?
of course, but the RTL only is receive only, so you technically can tune into those frequencies. So you'd be able to capture it and decode it, but just for sending it out, you need something like a HackRF.
Got it. Got it.
That's what I started honestly with an RTL.
Yeah. Okay. And then so a lot of the industry, correct me if I'm wrong here, this is my ignorance, but they came out with rolling codes, right? To kind of prevent that.
They did. They probably did way before I was even in university. But unfortunately, there are brands that, didn't implement it the proper way, or it was just not needed at some point. So some of them you can still find such issues, but it depends on how they've implemented it as well.
How prevalent is that? Like, I mean, would you say that you can, one out of every test that you do, or is it like five every 10 tests that you do? Like, you can just simply replay, or do they pretty much most of them do rolling codes now?
I want to say almost all of them do rolling codes. I haven't seen any car professionally that did not have rolling codes on them. But some of them you can do things like a rollback attack, but they mitigated that as well.
Ah, inform me. What's a rollback attack?
So instead of a standard just capture and then replay the same signal, a rollback attack's a little different. So even though a vehicle uses a rolling code, you can capture a set of three sequences and then replay that in a certain pattern, which then confuses the car, and the car thinks that an old code is still valid for it. So you're essentially just desynchronizing the counter on the vehicle.
Oh, okay. And how have they mitigated that?
That, unfortunately, I'm not sure. I'm still trying to find the answer to that myself. OEMs are very secretive and for good reason.
Yeah, right. So, what about other wireless systems as it relates to cars and vehicles? Are you attacking CAN bus? They all have some sort of cellular network as well now. To what are some of the other things besides the RF with the fobs?
With an RF, you said?
Yeah, yeah. Anything wireless. I know CAN bus is the internal system, right? Like, I guess what I'm wondering is what other just systems can you attack as it relates to a car?
So the way I look at cars now, they're just computers on wheels. You have a screen, you have all these fancy things in there. So the attack surface has increased, I want to say exponentially, just over the past like 5, 10 years. So some of the things that you could go for are the infotainment systems. They will generally have Wi-Fi, Bluetooth, BLE. BLE is even used for locking and unlocking the cars as well as driving them now, because you have phone as a key. You have tire pressure monitoring systems that also use Bluetooth now. That's a great attack vector as well. And of course, cellular and CAN externally on the car itself.
Okay, I have a ton of questions and
Of course.
a bunch of
Sure.
different. The infotainment, like underneath the hood, is there like like a handful of providers that provide the infotainment system to car manufacturers, so they don't have to like specialize in building that?
Yes, there are. So I've seen quite a few. I know some OEMs make them in-house. The screens, of course, I think are made externally. You have companies like Samsung that do a brilliant job at that. And I've also seen the infotainment operating systems and everything underneath is usually Android, QNX, or something along those lines. And many a times those are built all in-house, the software alone.
Okay. So is the infotainment systems, are you seeing them bridge together with like other systems in the car, like the CAN bus and other parts of the vehicle, like more and more, or are they still trying to keep them separate to some degree?
So I do believe they're trying to keep them separate. However, like for my car, for instance, like I drive a 2018 Honda. My infotainment's connected to the CAN bus directly. So it's still very limited, but in many a times we do see infotainment units that are connected direct to the CAN, but there is a lot of precautions taken in that case where they're separated, and you have something called the gateway that comes between them at times. So a gateway in a car is essentially like a firewall, so it prevents any unauthorized messages and things like that.
Okay. So do you find yourself, if say you have some sort of vulnerability that you're exploiting on the infotainment system, where do you go from there? What's your goal after that?
My goal, like for instance, just having an exploit on an infotainment system, the goal in my case would be to try and achieve CAN injection just through the infotainment. So to be able to attack an infotainment unit wirelessly, let's say over Wi-Fi, Bluetooth, cellular, whatever it may be, and then being able to inject CAN frames, in my opinion, is the coolest thing. I just want to turn my headlights on just through Wi-Fi. That'd be sick.
Well, I often think that, we're just a step away from like someone driving a car down the road. Now that we have cellular infotainment, getting to the CAN bus, like, could I remotely hack a car and like while it's driving 60 miles an hour down the road, tell the car to like engage in a parallel park sequence, and just like rip the wheel, and crash it. Like I know that's such a horrible thing to do, but like from a threat modeling perspective, I'm like, can that happen? So with your testing and the things that you're seeing, is that could that happen?
In theory, I guess anything can happen, but the good thing is that most, if not all, the vehicle manufacturers and vehicles out there, they're built with security in mind now. So a lot of these systems are designed to be fail-safe. So for instance, you have certain preconditions for an event to happen. So in case the car wanted to put itself into parallel park mode, if that was an event, it would need a set of lots of other conditions, such as, what speed you're going at. It might also even look at things like, oh, are you on a highway? If it had ADAS, if the car was able to see the speed of the cars in front of it and at the back, and, just different other things. But I personally haven't seen anything like this, but it might be possible for sure.
Yeah, it's just kind of one of those crazy things that, could it happen? And it's like, well, all the ingredients for the recipe to be cooked up is there.
I hope we never see that though.
Yeah, yeah, same, same. Just turn on headlights. That'd be cool. So let's talk a little bit about CAN bus. For those that may have just first heard that term, what is it?
So the CAN bus is the internal messaging system of the car, just like how we speak English, computers communicate over, I don't know, IP. The CAN bus is just its own internal messaging system. It's usually a two-wire cable that runs across all the different ECUs or computers in your car, and it's all based on hexadecimal. So it was invented in the 80s, super efficient. It was a perfect communication protocol for cars, just because when it comes to timing and a whole bunch of other things, CAN is one of the best protocols out there. But you also have other communication protocols such as LIN, Automotive, Ethernet, and several more things that are coming up more and more.
Next time we have you back on the podcast, you'll know more about that because you've tested it,
Definitely.
right? But using more Ethernet, is that just because the cars are demanding more and more events and more types of events and things like that, and it's just kind of the protocols not aging well? Are you just not seeing it yet in your testing?
I have, but I'm just not sure why it's becoming more prevalent. We regularly, I mean, it's only been about a year and a half, 2 years, so I don't really get to see too much of the OEM side.
It's okay. You're probably seeing more than our listeners here in that 1 year. So that's great. Let's talk about cellular, right? Pretty much a lot of things are connected to the cellular network just so they can have that wireless connectivity in internet connectivity no matter where they are. So if I were to give you, say, just a device, I'm a manufacturer, maybe it's an HVAC device or something, and I give it to you and I say, hey, it has, cellular capabilities. What type of attacks would you do as it pertains to that cellular connectivity?
So, assuming it's a black box device that I've just been handed, and the end goal is, hey, just hack it. the first thing I would do is rip the device open and look for something called an FCC ID. So the FCC essentially mandates everyone to have an FCC ID on any device that can send out any sort of wireless signals. And a lot of the times you are able to look all their test reports up just by having that FCC ID. So what I'll do is go figure out what that FCC ID is and then go look for the report online. You can go on fccid.io. It's a user-friendly site. You can download all the PDFs for any FCC ID. And with that, I generally look at what sort of technologies it supports. So if it supported GSM's ancient. I think it's been phased out most of the world. At least in the US, it has been completely phased out, where there supports 4G, 5G, and things like that. If it were just GSM, the good thing is, as an attacker, I can just create a fake cell tower with no authentication and force the device to latch on. Of course, this is all done in a very controlled environment. We have Faraday cages, which are boxes that prevent any signals from coming in or going out. And then essentially that device is forced to latch on to a GSM base station, after which you can do a bunch of things. When it comes to 4G, 5G, it does get a little more trickier there because they did increase the level of security on those technologies. So a lot of the times you're going to need something called a secret key, KI, and things like that from a SIM card. And usually it's only the telecom operator that knows this. You can't get it for your own SIM card. So there is a great programmable SIM provider out there, Sysmocom. So you can go get those SIM cards and essentially program your own SIM cards just using those, because those are blank. And so now, because you've programmed the keys yourself, you can put that onto your base station, which is something like SRS RAN, SRS LTE, or Open 5GS. And you could then make that device latch onto your 4G, 5G network. Following that, there's a lot of things that you could do. Like, surprisingly, a lot of times you can just do something as simple as an Nmap scan, and there are ports open. You can also forward all the traffic going from your base station to the internet and back, and then essentially just man in the middle everything over cellular, which is also amazing.
Okay, so you would do that to preserve its connectivity so you can watch the system do other things when it's actually functioning versus breaking its functionality, but out to the internet. Is that your goal?
Precisely.
Got it. You mentioned ports open. So there's still manufacturers that will have a listening port on that interface, essentially the cellular interface.
I wouldn't say manufacturers. I've seen it more with OEMs that use other cellular modems. So unfortunately, it becomes in a problem of, who your supplier is. Are they doing a good job at securing your telematics device or cell modem? So there is a lot of problem around that. But there have been instances where ports are just open. Like even the GPAC, I think it was one port was open and they weren't doing any sort of client isolation on the cell provider. So you were just able to talk to a bunch of devices over the same cell network.
Listen, if you made it this far, I'm just going to ask you for one favor. Most of you listening right now haven't subscribed. Go ahead, feed that algorithm, and support us by clicking subscribe. Doing so allows me to bring you great content and allows us to bring more exceptional guests onto the podcast. Go ahead, hit subscribe. I appreciate it. So I'm intrigued. If I want to, how hard is it to set up my own base station? Because I remember years ago, it seemed pretty complex and into the weeds. Is it easier to do so now?
Of course, I think it's far more easier to do now. Everything I learned was pretty much just YouTube and reading a lot of documents. And fortunate for us, there's actually this whole operating system designed for software-defined radios. It's called Dragon OS. And the person behind it is wonderful. He has a YouTube channel dedicated to setting up your own base station and things like that. What would take someone maybe week of learning, I think, can now be achieved in a few days. So from the software side, it is significantly easier now. However, the cost of cellular testing is still a little hard just because you need the right equipment. For instance, a Faraday cage before anything, because you don't want the FCC coming after you. I believe that's 5 years in jail, but you need that. Then you need a good radio transceiver like a USRP. They can run you a few thousand at least, but thanks to Alibaba, I was able to get mine for $600, which is not too bad. It was my graduation gift from a friend, which is amazing. And just these programmable SIM cards that can cost you anywhere from, I believe, $50 to $100. So it's not as hard as earlier, but there still are some challenges financially, to break into cellular testing or learn this from scratch.
Yeah, and a USRP, it's a type of SDR, right? Can you
Correct.
explain to our listeners what that hardware is actually doing?
Of course. So a USRP very similar to a hack RF, except I would say it's a hack RF on steroids. So instead of just being able to receive or transmit at any given time, you can do both at the same time, which is precisely what we need for anything cellular, because you need to send and receive traffic at the same time. So it's this device that you can receive and transmit signals at the same time, anywhere from 70 megahertz all the way to 6 gigahertz. So, yeah,
Interesting. So that hardware is actually needed when you start working with the 4G and 5G base stations.
precisely. I prefer the USRP just because you can use it for a bunch of other things, and it's a lot of the projects are built out for it, but you also can go for several other SDRs like the Blade RF, the Lime SDR, as well as Red Pitaya, I think. And there was a new one which is based on the same chip as the USRP, but it's built on a Pi, I think, and I found that pretty cool because you can just switch out firmwares and turn it from a USRP into a Blade.
Oh, that's pretty cool. We're gonna have to link those in some show notes.
Absolutely.
Because that is a high cost of entry, right? A USRP is not cheap. So if I can create a a base station for something cheaper to just to get started with the hobby, that would be
Precisely. But I
so.
think for anyone wanting to get into more wireless or like even learn cellular, I think DEF CON's a great place to have a whole wireless village dedicated. And they probably have base stations set up in a safe way. And, for people to go learn themselves without having to spend any money on the hardware.
That's actually a really good call out. The car hacking village and all the other villages at DEF CON would have all the gear that you'd want to try. So you could try before you buy, right? Figure out
Pretty
like
much.
where you want to go. Okay, cool. Are you involved with the car hacking village?
I am. I'm a mechanic for the car hacking village. So what I do is basically stand around in a mechanic outfit, and we help people hack the cars that we have there. So we've had Teslas, we've had Rivian, the OEM bring in their own car where they build a challenge out, and they just let everyone just come hack it. And yeah, they built CTFs around it. It was amazing.
Is it getting harder and harder, or is it getting easier?
I want to say it's
You're
getting
about to say
harder.
it. It's getting harder.
It's
That's
getting harder, and it's a great thing.
yes, that's a great thing for consumers and for everyone, right? But that also makes your job much harder.
Yes, but it also drives us to push a little more.
Yeah. Going back to the cars, earlier in the conversation, something stood out to me. You said the TPMS, the tire pressure monitor sensors, are now starting to use Bluetooth. Because before, didn't they just use like, was it 300 megahertz, 900 megahertz or something for
Yeah,
some RF?
yeah. They generally use 315 megahertz, many of them at least, but I've seen some of them using Bluetooth or BLE now. So it's not too different. It's just a different stack. So instead of just like regular frequency modulation or whatever modulation a regular TPMS would use, they're just using Bluetooth to send the same information out.
Okay. Okay. So the one thing I thought of is like if I wanted So I had a project personally at my house, which is, to put LEDs everywhere on the outside. So Christmas lights, nah, I'm going to do permanent, like, LEDs, RGB, so I could change the color and do all the sequence with WLED and all this stuff. And a part of me, the hacker in me, is like, I want to take this a step further. Like, I live kind of where people go in and out of my neighborhood, and I thought, wouldn't it be cool if I could like fingerprint cars that drive by and change it, right? So part of me is like, I think a fingerprint I could use is the TPMS sensor. Uh, I don't know. Would that be possible?
Of course, it's possible. Each of them have like a unique fingerprint, and I'd say it's definitely possible. I think
Yeah.
there was an issue in the US or somewhere else where there was a tire company or someone trying to get this information and then they would target people with ads. I don't remember. I remember reading this a long time ago.
I believe it because if like, I mean, I don't know if there's a better fingerprint on cars. I mean, nowadays they're driving around with, wireless access points in the cars themselves, but you can say at least any car made in the past 10 years is going to have a TPMS, and that's, always going to be there and easier to probably
But
promote.
let me know if you ever get that project working. I think that'd be a
I
sick project.
I think it would be kind of creepy, right? Like you drive by. I mean, the ads would, that would be creepy too, right? So hopefully there is a law against that because that's just. Ew. I'll let you know.
Definitely.
GPS spoofing, right? Like, there's cars, there's drones, there's all sorts of things that use GPS. Do you do a lot of GPS spoofing in the work that you do?
I do. So GPS spoofing is something that we regularly test for. For instance, it's not as serious as it is in drones. Like in drones, of course, if you're spoofing the wrong location, they can spin out, you can force them to land, and a bunch of other different things. But automotive focused, there could be instances where the car goes into a different mode when it's at a service location and things like that. I remember there was this incident in somewhere in Europe where a train they couldn't fix it because you'd need to be within like a certain like service location, and only then you would be allowed to repair the train. But a bunch of hackers spoofed GPS and were able to trick the train into thinking it was at the location and give them more access, so they were able to repair it.
Crazy. What, like, if I was to perform GPS spoofing, what tools and software do I need and environment? Like, how do you go about doing that?
Course. So for GPS as well, GPS L1 operates at 1.575 gigahertz, which falls exactly in the range where our hack RF or USRP can transmit. So again, you'd need an SDR, but you can do with a hack RF, which is significantly cheaper compared to more expensive tools. You'd need the hardware, of course. This time for a car, you'd of course need a much bigger Faraday cage. You could use anechoic chambers. They also sell these tents, just because, again, even GPS spoofing could cause harm to other people, so you need to be careful. And then the rest of it is open source tools. So there's GPS SDR sim on GitHub, which anyone can go download, and you need to go create an account with NASA to go download the positions of where the satellites are today. You parse it through GPS SDR sim, and you get a file that you can transmit through the hack RF, and then you can basically be anywhere on the planet. And you can also manipulate time, just because GPS also sends out time. And many devices, they trust GPS and they rely solely on GPS for time, which is another issue because you can roll back certain dates and cause crashes. And if you're not validating the GPS signal coming in, you can do a lot more damage. If the software is just accepting the signal as is and trying to process it, there are certain fields that you could tamper with, and some cases do a complete denial of service of any device.
Interesting. So, why do you need the file from NASA where all the satellites are located?
Of course, that's a great question. So our phones kind of know the date and where we are at the moment. The NASA files just are for a given date, a satellite's probably at a certain location. So GPS SDR sim looks at that, looks at the constellation of the most recent date, and then it will try and like rearrange the satellites in a certain way so that your phone calculates that, you're somewhere else instead. So it just rearranges that constellation for your any device or a car, phone, whatever it is, to think that it's somewhere else based on where those satellites are located.
Got it. Got it. And like, what is the range? I mean, you probably mostly do this inside a Faraday cage,
Yeah,
but
yeah.
like, I mean, if there's a malicious actor, like, are you bound to the range that you can use with a hack RF, or how far of a range can you spoof?
So with the HackRF, I think the maximum you could do at that particular frequency, I want to say around 20, 25 feet. Of course, there would be some interference beyond that. But if you were to add something like a power amplifier, you can do a lot more. So you have these power amplifiers that anyone can go buy that, go 60 watts that can do a lot more than 20 feet.
There's a project that I that did a while ago that basically would essentially identify the commands using, I think, is Mavlink, that were being passed to the drone, and then realize that you could just pass it whatever, and there's no security built in at that time. So it's like you could just pass it whatever you want when it was within range and give it the kill command and just drop out of the air. That was pretty cool. That was using the Mavlink protocol.
I remember there was a Northeastern lab for it. While I was interning at Northeastern, I remember one of the classes for the labs, they had this drone where it was using Maverick.
I think it was just a Pixhawk flight controller.
Yeah, yeah.
I don't know if that's still the case now. Hopefully it's not. But what's hard there though is like some of them were on, using frequencies you can't encrypt, right? Too, as well. So there's a difference between the confidentiality of the protocol as well as the integrity what's being sent to it. But I just remember that was always a challenge, right? It's like, okay, you can't send encrypted stuff on this frequency. Does that come into play at all with some of the work that you do?
Trying to speak on a communication protocol that's encrypted at a certain frequency, or
That, and like, just are there devices that you're testing that use frequencies that can't have encryption, so therefore it weakens their security?
that's a tough question. I want to say GSM. You that GSM's the only thing that you can't really have encryption on, I guess, but nothing that we intercept really. We don't really intercept anything going over the air. It's all very controlled, like very very small environment.
Yes, I can see why. If I wanted to get started doing some of the cool testing that you're doing, you mentioned YouTube, but what has helped you really learn and level up on this topic?
It's a great question. Thank you for asking that. YouTube for certain, and I also highly, highly recommend the Cyber Auto Challenge. It's a challenge aimed at students. So if you're attending college, you just go do an application, and then they have a week-long event that's completely paid for, where you'll have OEMs bring in, their vehicles, things that, even pre-production, really. And you, as a student, you don't pay for any of this. You have a week long of classes where they teach you, things like RF, CAN, everything there is really. And then you have about 24 hours to go hack any of the devices that they have. So you have 24 hours to go take everything you've learned, go hack a real device, write a report, or, make a presentation about it, and then give it to an OEM. And I think that's really cool. And if you can, definitely attend DEF CON. The car hacking villages there. We collaborate with OEMs. They bring their infotainments. They bring a bunch of different things that you wouldn't otherwise be able to hack unless you owned it. And best part is that most of them are like built on security issues that people have seen in the past. So it's really not gamified, and it's something that you can go learn and then maybe try it out on different devices.
That's awesome. So the Cyber Auto Challenge, it sounds a lot like the Collegiate Cyber Defense competition that they host for the red team and blue teams. That is awesome. That's free. And that's always the hardest part about getting into the car hacking specifically, is that it's such expensive targets, right? Like, sure, I have a car, I could go rip it apart and like start testing on it, but like I have to drive it to work tomorrow.
I agree. Yeah, definitely do not hack your car. I remember about recently, I think it was November, my friend and I decided to start poking at my car. And let's just say Christmas came early. There were lights on the dashboard that came up that I didn't even know existed. So it's definitely not a good idea.
Did you get them to go away?
Yeah, eventually.
That's crazy. Well, cool. This has been a great conversation. Ayyappan, if someone wants to follow the work or get that you're doing, or just get in touch with you, how can they do so?
Definitely. Thank you for having me, first of all. And if anyone wants to get in touch with me, I'm reachable on LinkedIn. My name's Ayyappan Rajesh, and yeah.
Awesome. Thanks, Ayyappan.
Awesome. Thank you.
If you've made it this far, do me a favor and check out what we do at Sprocket Security. If you're ever in need of a penetration test and you want that hybrid scalable approach, the always testing, always on, not this fake click a button, do a pen test 2 weeks and then do that 5 times a year. No, I mean always on, always testing, latest bleeding edge threat that comes out there, latest exploit, phishing, all the way to, defense evading, covert operations, whatever type of pen test you need. We'll do it as frequently as possible, and we'll also provide a platform for us to interact together. I've devoted the last 5 years of my life to building penetration testing and innovating upon it and changing it so you can actually do security testing, proactive security testing, in a much better way. Give it a shot. Check us out, www.sprocketsecurity.com.